Okay, let's try sample problem 1.1. It says here that the normal human body temperature can range over the course of the day from about 36 degrees Celsius in the early morning to about 37 degrees Celsius in the afternoon. Express these two temperatures and the range that they span using the Kelvin scale. So there are, in general, 3 temperature scales that we would be concerned with. There are other temperature scales out there, but there's only 3 that we really talk about in general chemistry. The first is Fahrenheit, the second one is Celsius, and the third one is Kelvin. So this is a conversion problem between Celsius and Kelvin. So I'm going to write it this way. I'm going to write down our 2 temperatures, and I'm going to write it this way. T sub C, meaning the temperature in Celsius, is 36. And then our other one is T sub C equals 37. Now, the equation for the conversion between these two is that the temperature in Kelvin is equal to the temperature in Celsius plus 273.15. Usually for most calculations, you can round it off to 273. So for this one, we'll do that. Okay. Let me actually put it, the entire equation there. Okay, so let's do the first one. The first one is 36 degrees C. So the temperature in Kelvin would be 36 plus 273. So that looks like it's 309. And then the abbreviation for the unit Kelvin is an uppercase K, not lowercase, but uppercase. So this is 309 Kelvin. So notice Kelvin temperatures are always greater than Celsius temperatures because you're adding 273. Let's try the second one. 37 plus 273. And you get 310. Oop. I think I wrote an extra 1 in there. Okay. So notice the 2 scales. So here's our degrees Celsius scale. 0 on the Celsius scale is the temperature that water freezes. 100 is the temperature that water boils under normal conditions. Okay? So what we have here is, let's put in 20, 40, 60, 80. Those are not perfectly spaced, but you get my point, right? 20, 40, 60, 80. So we're really looking at 36 and 37. So that's one of those temperatures is right there. And then the next one is right next to it, 36 and 37. On the Kelvin scale, which by the way, there's no degree sign for Kelvin, it's just K for Kelvin. This occurs at 273. And this occurs at 373, right? Because you're adding 273 to the Celsius. Okay. So 20 is 293. 40 is 313. 60 is 333. And 80 is 353. Okay? So really this happens then right here and here at temperatures of around 310. That's not a very big variation if you think about it, right? if you look at the entire range of your temperature during the day, you're really going from 309, that's your minimum, right? That's the smallest value, to 310 Kelvin, that's your maximum. Of course, that's typical. It could go a little bit beyond that range, but that's not a very big difference, right? And for those of you who are biology majors, particularly those of you that are interested in medicine, that's significant, right? That shows you how tightly regulated temperature is in the body, so that throughout a day, if you're healthy, that temperature is locked in to a very small variability. And that, of course, is an important issue in physiology. So there you go, sample problem 1.1.